Let's dive into the basics of computer networks. What do you think is the most transformative aspect of network evolution?
I'd say moving from ARPANET to the Internet has been revolutionary, especially with the introduction of TCP/IP. It's the backbone of modern networking. But what about the different network types?
Each has its place. LANs for local connectivity, WANs for wide scale, and MANs for metropolitan areas. But how do you feel about network topologies, like the choice between a bus and a star?
Star topology has become more popular due to its scalability and fault tolerance, unlike the bus, which can fail if the main line goes down. Speaking of which, what's your take on the OSI model versus the TCP/IP model?
OSI's 7 layers offer a theoretical framework, but TCP/IP's 4 layers are more practical for real-world application. The abstraction in OSI is useful for teaching, though. Let's move to the physical layer. What are your thoughts on transmission media?
Optical fiber, with its high bandwidth, is ideal for backbones, but twisted pair is still king for most LANs due to cost and ease of installation. But when we talk about bandwidth versus throughput, what do you see as the main difference?
Bandwidth is the potential capacity, while throughput is what you actually get under real conditions. Now, error detection at the data link layer. Do you prefer CRC or checksums?
CRC for its robustness, though checksums are simpler. And when it comes to Ethernet, its frame structure is quite efficient, right?
Absolutely, but switches really enhance that by learning MAC addresses. How do you approach VLANs in network design?
VLANs are crucial for logical segmentation. They allow for better security and traffic management. What about the network layer? IPv4 versus IPv6.
IPv6's adoption is slow due to IPv4's NAT, but its address space is necessary. CIDR was a game changer for IPv4 management too. How do you manage routing?
Dynamic routing protocols like OSPF for internal and BGP for external networks are key. Static routing has its place, but for large networks? No way. What about transport layer protocols?
TCP for reliability, UDP for speed. The three-way handshake in TCP is basic, but essential for connection reliability. How do you handle port numbers in your configurations?
Using well-known ports for services, but always ensuring they're not exposed unless necessary. Security at the application layer with HTTPS and DNS? How do you see it evolving?
HTTPS is becoming the standard, and DNS security with DNSSEC is on the rise. Email protocols like SMTP are still fundamental, but what about newer challenges like DDoS?
DDoS mitigation involves a mix of traffic analysis, rate limiting, and load balancing. Firewalls and IDS/IPS systems are crucial. How do you ensure network security policies are followed?
Regular audits, access controls, and educating users. Physical security often gets overlooked. How do you address that?
Securing physical access to network hardware is as important as cybersecurity. Now, with virtualization, how do you think network administration tools have adapted?
Tools like Wireshark for packet sniffing have become even more vital for troubleshooting virtual networks. What about network management protocols like SNMP?
SNMP is still widely used for monitoring, but it's being complemented by newer solutions for cloud environments. Speaking of clouds, how do you see cloud networking impacting traditional setups?
It's pushing for more software-defined approaches like SDN, which we've been discussing. But the integration of IPv6 in cloud environments, how challenging is that?
It's an ongoing transition. Dual-stack networks are common, but the real challenge is ensuring all services support IPv6. How do you manage QoS in such an environment?
QoS is about prioritizing traffic, which in a cloud can mean ensuring real-time applications like VoIP have the necessary resources. What about edge computing in networking?
Edge computing reduces latency by processing data closer to the source, which is crucial for IoT. But how do you see 5G influencing network design?
5G promises higher data rates and lower latency, which means we might see more distributed network architectures. Lastly, how do you keep up with the continuous learning in this field?
By staying engaged with community forums, attending conferences, and constantly reviewing new standards. Networking is ever evolving, and so must we.
We touched on a lot, but let's delve deeper into network troubleshooting. What's your approach when you encounter a network issue?
I start by defining the problem, then use tools like Traceroute to isolate it. But what about when you're dealing with a complex setup like a hybrid cloud environment?
That's where understanding the integration points between on-premise and cloud becomes critical. Have you found any particular tools helpful for these scenarios?
Absolutely. Tools like NetFlow or SFlow for traffic analysis are invaluable. They help in understanding where traffic bottlenecks occur. How do you handle documentation in your networks?
Documentation is key for troubleshooting and future planning. I maintain detailed network diagrams and configuration backups. What about security and documentation?
Security in documentation means limiting access to sensitive information. But let's talk about network security at a deeper level. What are your thoughts on the CIA triad?
Confidentiality, integrity, and availability are the pillars. But ensuring these in a modern network with BYOD policies is challenging. How do you address this?
BYOD requires a robust MDM, mobile device management system, to enforce policies. Speaking of policies, how do you ensure compliance with network security standards?
Regular audits and penetration testing are essential. But with the rise of IoT devices, how do you manage network security?
IoT devices often lack robust security features, so segmenting them into their own VLANs is crucial. What's your approach to managing IP addresses with so many devices?
Using DHCP with reservations for critical devices and implementing IPv6 where possible. But the transition to IPv6, how do you see that progressing?
Slowly, due to legacy systems and NAT's efficiency in IPv4, but it's inevitable. On another note, what about the architecture of modern web applications?
Microservices and containerization have changed the game. How do you handle networking in environments like Kubernetes?
Kubernetes networking involves understanding service discovery, load balancing, and network policies. But what about the challenges of scaling these services?
Scaling involves ensuring network resources are dynamically allocated. How do you see SD-WAN fitting into this picture?
SD-WAN offers centralized control over a wide network, improving performance and cost efficiency. But how does this change traditional WAN management?
It abstracts the complexity, allowing for policy-based traffic management. But with this abstraction, how do you maintain visibility into network operations?
Visibility tools and telemetry become more important than ever. What about the impact of 5G on network design?
5G could lead to more edge computing scenarios, reducing latency significantly. But how do you plan for this integration?
Planning involves ensuring backhaul capacity and preparing for device proliferation. What about the security implications of 5G?
More endpoints mean more potential vulnerabilities. Robust encryption and identity management are more critical. How do you see the role of AI in future network management?
AI can predict network issues and automate responses. But there's also the risk of AI being a target. How do we secure AI in network operations?
By ensuring AI systems are isolated, data is encrypted, and models are regularly updated for security. Let's shift gears. What are your thoughts on network redundancy?
Redundancy through protocols like VRRP or HSRP ensures high availability. But how do you balance redundancy with cost?
It's about finding the right level of redundancy for the risk profile. And speaking of risk, how do you approach disaster recovery in networking?
Disaster recovery involves having off-site backups, redundant paths, and quick failover mechanisms. But in a world moving towards cloud, how do these strategies evolve?
Cloud strategies include geo-redundancy and multi-region deployments. But ensuring network performance across these regions can be tricky. What's your approach?
Using CDNs for content and global load balancers for application requests. But how do you manage latency in such setups?
Latency management involves optimizing data paths, using DNS wisely, and sometimes embracing edge computing. With all these advancements, where do you see networking headed?
Towards more automation, integration with AI, and an ever-increasing focus on security and privacy. Networking will continue to be about connecting everything more efficiently and securely.
We've discussed a lot about network security and performance, but what about the impact of quantum computing on network encryption?
Quantum computing could break current encryption methods, pushing us towards quantum-resistant algorithms. But how do you see this transition happening?
It'll be a gradual shift as we develop and standardize new cryptographic methods. The challenge will be retrofitting existing networks. What about the role of blockchain in networking?
Blockchain could revolutionize secure data transmission and identity verification. But it also introduces overhead. How do you balance this with network efficiency?
By using blockchain only, where the benefits justify the cost, like in secure peer-to-peer networks. Let's talk about the evolution of routing protocols. What's next after BGP?
There's research into path-aware networking, where routing decisions are more dynamic and based on path properties. But how do you see this affecting network neutrality?
It could challenge neutrality if not implemented carefully, as paths could be selected based on more than just the shortest distance. What's your take on the future of network addressing?
IPv6 will become more prevalent, but we might see new addressing schemes for massive IoT networks. How do you think network infrastructure will adapt to this?
Infrastructure will need to be more flexible, possibly leveraging mesh networks more for direct device-to-device communication. But managing such networks?
Management becomes decentralized yet coordinated, possibly through AI-driven systems. How do you think this impacts network management tools?
Tools will evolve towards more predictive and proactive maintenance, using machine learning for anomaly detection. But what about data privacy in these AI systems?
Privacy will be a major concern, leading to more on-device processing to minimize data exposure. How do you see this affecting network latency?
Latency could decrease as processing moves closer to the source, but it introduces new challenges for network synchronization. What about the role of 6G?
6G is expected to enhance 5G's capabilities, bringing in terahertz frequencies for even lower latency. But how do we ensure these frequencies don't interfere with existing systems?
Through advanced spectrum management and possibly dynamic spectrum sharing. Let's shift to network virtualization. How do you approach security in a fully virtualized environment?
Security in virtualization involves microsegmentation and strict control of VM interactions. But what about the performance hit from this level of security?
It's a trade-off, but advancements in hardware virtualization help mitigate this. What about the integration of AI in network devices themselves?
AI in devices could lead to self-optimizing networks, but securing these smart devices against AI-driven attacks is paramount. How do you envision network monitoring evolving?
From reactive to predictive, with AI helping to foresee network issues before they impact users. But what about the ethical implications of such pervasive monitoring?
Ethics will dictate transparency and user control over data. Moving to network programmability, how do you see this changing network administration?
Programmable networks allow for rapid deployment of services and policies, but administrators will need coding skills. How do you think this affects job roles in networking?
Roles will shift from manual configuration to more strategic, policy-based network design. But what about the traditional network engineer's role?
They'll become more like network architects, focusing on system design, security, and integration. What about satellite internet's role in network topologies?
Satellite internet could bridge the digital divide in remote areas, but latency is still an issue. How do you see this affecting global network design?
It could lead to more hybrid network models, combining terrestrial and satellite for resilience. But how do you manage such a diverse network infrastructure?
Through unified management platforms that can handle multiple network types. What about the role of network slicing in 5G and beyond?
Network slicing allows for customized network services, but it complicates network management. How do you approach this complexity?
By automating slice management and ensuring clear service-level agreements. What about the future of wireless mesh networks?
They'll become more common for coverage in urban areas or disaster recovery, but security and interference will be ongoing challenges. How do you see network troubleshooting evolving?
Troubleshooting will become more data-driven, with AI helping to correlate issues across complex networks. But how do you keep human expertise relevant?
Human oversight for interpreting AI insights and handling exceptions will remain crucial. Lastly, where do you see the biggest innovation coming from in networking?
I believe it's at the intersection of AI, quantum computing, and network virtualization. These technologies will redefine how networks operate, secure, and scale.
Let's dive into the specifics of structured cabling. How do you ensure adherence to standards like TIA/EIA in large-scale installations?
It's about meticulous planning, from cable management to ensuring patch panels are correctly labeled. But what about the practical implications of using different cable types like CAT5 versus CAT6?
CAT6 provides higher performance and less crosstalk, but at a higher cost. For high-speed environments, it's crucial. How do you approach switch configuration for VLANs?
I start by defining the VLAN scheme based on organizational needs, then configure trunk ports to allow inter-VLAN communication. Have you dealt with spanning tree protocols in these setups?
Yes, to prevent loops. STP can add latency, so I often use Rapid STP for quicker convergence. Speaking of configurations, how do you manage router setups?
I focus on route optimization, setting up dynamic routing where possible, and using ACLs for security. What's your strategy for basic firewall rules?
I advocate for a deny-all approach, opening only necessary ports to minimize attack vectors. But how do you handle network addressing plans?
It's about logical segmentation by department or function, ensuring scalability and manageability. What about redundancy and failover in network design?
Redundancy involves multiple paths or devices, like using HSRP for gateway failover. How do you implement quality of service, QoS, in your networks?
QoS is vital for VoIP or video. I prioritize traffic based on DSCP markings and use traffic shaping. But how do you manage the shift to cloud networking?
It's about adapting traditional network concepts to virtual environments, using security groups and virtual load balancers. What's your experience with IPv6 deployment?
Dual-stack networks are common, but enabling SLAAC for IPv6 auto-configuration simplifies management. How do you handle DNS load balancing?
I use DNS round-robin for basic load distribution, but for more sophisticated setups, I integrate with application load balancers. What about edge computing?
Edge computing is about placing computational resources near data sources for lower latency. How do you see 5G fitting into this?
5G enhances edge computing by providing the necessary bandwidth and low latency. But how does this change traditional network troubleshooting?
Troubleshooting now includes understanding where data is processed. But the basics remain: identify, isolate, fix, and verify. How do you manage network documentation?
It's crucial. I maintain diagrams, configurations, and change logs in a centralized system. But with all this technology, how do you stay updated?
Continuous learning is key, through certifications, webinars, and networking communities. What do you think is the next big trend in networking?
I'm betting on further advancements in SDN and AI for network automation and prediction. But how do you see these technologies impacting job roles?
Roles will evolve into more strategic positions, focusing on orchestration and policy rather than manual configuration. How do you prepare for this shift?
By learning programming and automation tools and understanding business needs more deeply. It's an exciting time for network technology, isn't it?
Absolutely. The field is continuously expanding, with endless opportunities for innovation and improvement.